In this video, we will explore 4 industrial measuring tools: rulers, dial calipers, micrometers, and dial indicators. Let's begin with the simplest type of measuring tool, a straight-edge ruler. It has equally spaced markings along its length and may be used for technical drawing, measuring distances, or drawing straight lines. Rulers can be of many types. Some of them include steel rule, desk ruler, carpenter's rule, seamstress tape, architect's scale, and tape measure. Steel rules can be made in many sizes and formats. Most are 6 or 12 inches long and can be flexible or rigid in form. There are many options for graduations, but most good ones have uniform graduation line widths. They are usually created from hardened and tempered high-carbon spring steel and chrome-plated. This protects against corrosion and helps readability. A common and versatile tool used by engineers and manufacturers is a dial caliper. It is used to measure the length, height, depth, inside diameter, and outside diameter of a given object. A standard inch dial caliper measures around 6 inches. The immovable portion is called a blade. The slider moves along the blade and is used to adjust the distance between the measuring surfaces. The pointer rotates within the dial as the slider moves back and forth along the blade. Larger increments are kept track of with the reference edge. The rack and thumb wheel allow for a controlled, fine movement of the slider when making a measurement. To set 0, you have to loosen the bezel lock screw and rotate the bezel so the 0 mark on the face is aligned with the pointer. Then retighten the screw. Then the object is held between the jaws and locked. Adding the main scale reading and the dial scale reading gives the measurement of the value. Note that the slide lock thumb wheel can be used to hold the slider in place in order to move the caliper to hold measurement value. The third measuring instrument is a micrometer. As with the caliper, micrometers are available in a digital format. Micrometers come in various sizes and can measure within a range of around 1 inch. Few parts of a micrometer are stationary and others can be moved. Anvil, frame, and sleeve are stationary. A thimble or ratchet knob can be turned to move a spindle to make a measurement. They are used to measure the length, width, and diameter of a given object. First, the spindle is closed by rotating the ratchet, and the 0 line on the thimble is lined up with the 0 line on the sleeve. This is a validation step to ensure that the micrometer is calibrated, adjusted properly before taking a measurement. If it isn't, then the tool would have to go through a calibration adjustment procedure. Then the spindle retracted so the object to be measured can be placed between the anvil and the spindle. Then the spindle is tightened using the ratchet till. To get the value of the diameter, the reading on the sleeve is added with the reading on the outer barrel at the point of their intersection. The last type of measuring tool is a dial indicator or a dial gauge. They are typically used to make small, high-resolution measurements. The outer face scale of a dial indicator can be rotated to set 0, similar to the manner shown for the dial caliper. The inner face scale is smaller and stationary. It is used to count the number of pointer revolutions in order to determine the total measurement. In this example, a dial indicator can be used to determine the flatness of a part's surface. The indicator body is fixed relative to a reference surface and set to 0 with the plunger having sufficient travel to extend and retract to maintain contact with the part's surface, ensuring measurement. As the part resting on the same reference surface noted above is moved to various locations to make measurements, the needle position varies from 0 and the change in value can be recorded. It is also used to check shaft alignment, run out, and soft foot.